Another fine example of rigidity in space, one of the gyroscope assets. As you can see, because the spinning disc is spinning on the vertical plane, it wants to continue. That force of wanting to continue is stronger right now than the force of gravity trying to pull this down. Because if it was not spinning, it would fall right down. This would not be staying up on this string. This force of wanting to stay in the plane that it's in is what provides the inertial or the initial datum that's used in things like flight instruments. Now this here is precession. Precession is the cone in space that's shaped when the top or gyroscope starts spinning. So as you can see, now it's an upside down cone, obviously getting wider as it gets lower, but as you can see, there's nothing holding this up right now but just the force of that spinning, because now we're spinning on the horizontal plane and it wants to continue. But as the space changes, as the forces change, it starts to describe that cone, that precession, in this case torque-induced precession. And how low can you go? This thing gets literally off of the ground by just a hair, at least one or two good revolutions before it actually falls all the way. Now the extension that it's on is just one piece, and it's only about 2.5 inches, maybe 3 inches. So this one now we have two of the extensions, and you'll see that the top of the sphere is just about 7 inches off the ground. And we're going to let this one spin again. Now, again, just strictly balancing by that gyroscopic force. But yet that force is greater still than the force of gravity trying to pull this over. And as you can see, even at a longer extension, it still gets very close to the ground before it touches.